Hello, I'm James Ingram for AutoControls-dot-org. In this video, we'll be using NCE Mini Panel to operate 3 O-gauge engines on the same point-to-point track that you can see here using one detector and no blocks. What we've got here is a 3 MTH O-gauge Proto 3 locomotives sitting on a 16-foot, 8-inch long section of MTH reel tracks. And you can see down there in front of that last diesel, there's a standard MTH track connector and a Z-Step infrared detector. And up here on the near end, we have an NCE, what is called an NCE Mini Panel. That's this little device right here, and that's what's doing the controlling. And this is our start switch here, this button, and this is a reset switch. And this is just essentially a single pole, single throw switch we can use. It's connected to input 18. We can use this to cause it to run multiple cycles if it's closed like now, or if it's open like that, it'll just run a single cycle of all 3 trains down and back. And then here we've got an NCE Power Cab that's powering all 3 of these. And NCE says not to use the Power Cab for O-gauge. I'm violating the recommendations because it really doesn't have enough amperage. I can get away with it for this experiment because we're only running 1 engine at a time, and we're running very slow speed step 2. The big deal here is, in my opinion, we can do all this with no blocks. There's no blocks in the track. This is just a continuous piece of track. We'll push the start button.
Looks like we've got a 4B on the way.
You can see the detector went red. Now it's back to green. When that detector went red, it started executing a time delay that'll position that white locomotive at the far end of the track. It's executing about a 27-second time delay. Now the first engine stopped. You can see the second engine's in motion. And it'll just keep going until that engine crosses a detector, which you can see it'll go to red in a minute. There it did. Now the mini panel, that is to say the controller, it's executing an 18-second time delay to position that green engine down in the location where we want to park it. Now that engine stopped. Now the third engine started up, the yellow engine, and that'll proceed until it crosses a detector. They just run until they get to the detector. There's no measurements being made, but once they cross a detector, then the mini panel starts executing the time delay to park the locos in the proper position.
We're ready to go.
That one, the yellow one, it'll run that one for 11 seconds. And again, you can see they park approximately where those white pieces of cardboard are. As I mentioned earlier, those white pieces of cardboard indicate the approximate parking positions of the locomotive. Now it did a 7-second time delay at the end, and then it started that yellow locomotive in reverse. You can see it's coming back now, and again it ran until it ran in reverse till it crossed the detector, and then the controller starts executing another time delay coming in reverse. I think it's about a 26-second delay to bring it back here and park it at the end of the track. They can see that loco parked about where the white piece of cardboard over there is. Now the green engine's coming back, and it's just running free, but when it crosses the detector, the controller will start executing a time delay. In the case of the green one, it'll execute about a 19-second time delay and then tell the locomotive to stop. I should have mentioned that we execute a time delay, and then we send the command to stop the locomotive, which is a speed 0 command. Now the second engine is back and parked. The third engine's coming back. And that'll just keep running until it crosses the detector. When the detector goes red, that'll start executing for this loco a 12-second time delay, and that'll bring that engine back to its position. Now you can see all three of these locomotives are back and parked in their original position. There's a knife switch over there that I pointed out earlier on the corner, and if that switch is open, it'll just run a single cycle. If that switch is held down, it'll run multiple cycles. Here's a closer look at this Z-Stuff infrared detector. This is a DZ1012. The standard DZ1011 would work just as well. I use the DZ1012 because it has a little bit brighter light, which I think is better for the video. But basically what it does, it throws out an infrared beam at about 45 degrees, and it'll be green like you see it now, as long as that beam's not interrupted. When a locomotive or something comes along, or a car comes along and interrupts that beam, you can see it changes from green to red. And then when the train goes through and it clears the beam so it's not blocked anymore, it changes back to green. And that's connected to back here where my finger is. It's just a little square thing, a Z-Stuff DZ 10008 single pole double throw relay, and as it's shown here, it's wired to the normally open contacts of the relay. When something activates the detector by blocking the beam, this block signal detector causes the relay to close, and those normally open contacts go to closed, and that's what signals the controller, that is to say the mini panel, that a train is there or something's there, and it takes appropriate action. In the case of this video, what we're doing is we're just using time delay to park these trains. That's how we can do it with no blocks. When a train goes down and when it sets that detector to red, we start doing a time delay and timing a certain number of seconds to cause the locomotive to stop where we want it to stop. And this detector is not really connected to the track, it's just sitting here. You can see I can pick it up and move it away. And that's what I like about using these infrared detectors. You don't have to mess around with attaching anything to the track. If we take a walk along the main line, so to speak, I'm at the west, what I'm calling the west end of the layout, considering these trains traveling west to east. You can see just a piece of track. I just have a jumper here to connect the two outer rails. But we have the first train, some track, the second train, some track, and the third train, some track. This isn't part of it normally. We have more track. Here we have the detector. The detector is approximately in the middle of this layout. It doesn't have to be in the center. It can be anywhere. The center, close to the center, is good because you're measuring time each way from the detector, and it cuts down the error. I should say it minimizes any error you're going to get if you can keep it closer to the center. But in one of the previous videos, I think it was 822, we actually had the detector at one extreme end of the layout. That was just running a single train, but you can use the detector at one end, especially if you're running just one train. Here's a standard MTH track connector, and again we've got more MTH reel tracks going down to the end, and again we've got another pair of jumpers just to connect the ground rails together. But you can see, looking at this simple little layout, again, the thing that's nice, I think, is there's no blocks involved. You can do this, what I think is a fairly interesting operation with just simple track, no blocks, one detector, and the mini panel to control it all. With all three engines on the track, you can see it's pulling, the system's pulling about 0.6 of an amp. That's all three engines with the sound operating. Now if we start that engine up, you can see it goes up to around 9.9 amps, just under 1 amp. But still we're running, most of the time we're staying under 1 amp of current draw, and this thing's good for 1.8. So again, even though you're not supposed to use this for O gauge, we can get away with it just running one engine at a time at a very slow speed. There's a little 8-step test routine we can use just to verify the detector and the push button is hooked up. The mini panel has an LED on it, and that LED will blink if I push the reset switch here. If you watch about right here, hopefully you'll see a blinking flash. There it goes, there it goes, there it goes. Right there, there was a blinking flash, and that mini panel makes that blink if you push the reset switch. And our test routine uses that same LED. We send a dummy command to throw a turnout that doesn't exist. There's no turnouts on this layout, but we can send a command to throw a turnout, and when it sends that command, it'll make that LED blink. Said another way, whenever the mini panel sends a command, the red LED will blink. So again, we'll go to our test. Just 3, test operation, input number 3, and enter. So now we should be running the test routine. So if I push down on the start button here, you can see that mini panel blinks. That red LED is flashing. If I let go of the start button, it stops flashing. Now if I block the detector, and this is probably the most important test to make sure the detector is hooked up and the mini panel is seeing it properly. If I hold my hand in front of that to cause it to go red, you can see again that causes the mini panel to flash. And if I take my hand away, that goes back to green. The relay contacts go back to open, and the mini panel stops flashing. And then there's also a test for this switch. If I close this switch, you can see that causes the mini panel to blink. And in fact, if I hold my hand in front of the detector and the switch is closed, you can see it blinks fast. Or having two of the inputs closed, it's sending that command twice as fast, which causes it to blink twice as fast. But at any rate, that's a simple routine we can use to verify that our inputs are hooked up properly and the mini panel is detecting them. Now we're down at the other end of the track. I'm going to run down there and push the start button again.
Cmds detected out.
Now again, we're executing that time delay since the engine crossed the detector. You can see the first engine coming down. It's running on a 27-second time delay. part of it's out of the camera, but you can see it sitting at the end of the track. Here comes the second engine. And again, it'll start about where those white pieces of cardboard are. Now that engine stopped, and the third engine, the yellow engine's on its way down. And again, it just runs until it crosses the detector, and when the detector detects the train, it closes a relay that's part of that detector assembly, which signals the controller, the mini panel, that the train has crossed the detector. And from that point on, it executes a time delay to run the engines up and park them in the appropriate position. Now that engine parked, it'll wait about, the controller's programmed to wait about 7 seconds, and it'll start running them all back in reverse. This system depends on these engines running pretty consistently speed-wise, because we're using time to estimate distance. So if the engine runs faster, it's going to go a little bit further than we expected. If it runs slower than normal, it's going to go a little bit less than we expected. But any error we accumulate is essentially reset when we cross the detector the next time, because it starts a new measurement. Now that yellow engine arrived at the far end of the track. Now the green one, you can see, is backing up.
That knuckle set?
These are all three Proto 3 engines, and Proto 3 engines, MTH Proto 3 engines, will run on DCC as well as DCS. We're operating them on DCC for this video. The yellow one and the white one, they are Premier, which have the switch. The Premier engines have the switch to switch them from DCS to DCC. The green engines are Rail King. It didn't have the switch, but we added a switch to that engine. The Rail King engines reportedly had the switch from about 2011 to 2014. But Rail King engines made after 2014 did not have the switch. Now I closed another switch that's connected to input 18, which tests if we run it again. So what happened is it's starting a second cycle. You can see the first video section, it ran once and stopped, but now it's starting to repeat itself. And as long as that switch is closed, it's connected to input number 18. As long as that switch is closed, these engines will keep repeating. So what that means is you can set up this push button arrangement like we're using to start the trains here on a public display, and you can have it such that if the public pushed the button, they would run one cycle down and back and park themselves. Or you could have it so that if they push the button like you're seeing here right now, they would keep running continuously until you open that switch number 18 that's causing it to run continuously.
Get B&B to check that out.
Now there's the third engine coming down. And recall, we're doing this in 3-rail O gauge, but this setup will work for really any gauge, N gauge, HO gauge, S gauge, 2LO gauge, or large scale. And a lot of the Lionel S gauge engines have the ability to run on DCC. Okay, now there's the end of our second cycle. I shouldn't say the end, there's the middle of our second cycle. Now it's completing the second cycle by running these trains back to the original position.
Okay, ready to pull out.
As I mentioned, I'm using what they call the NCE Power Cab, which has a maximum amperage rating of 1.8 amps. And it's really undersized for these trains. NCE says not to use the Power Cab with O gauge. I can get away with it because we're running only speed step 2 here, so even when they're running, they're only pulling about an amp. And there's only one locomotive running at a time. To me, the speed step 2 that you're seeing here gives a speed that looks realistic for running through a yard. You could, of course, run them faster, but then you eat up your track, so to speak, a lot quicker. If you run them slower, it kind of gives the appearance of having a longer main line. Now that just completed the second cycle, and again, since that switch number 18 is still closed, it'll start repeating a third cycle. You can see the white engine that's parked up here and the green engine that's on its way down. They both have rooftop beacons. The white one was built in to that loco. The green one was added. But I like the beacons because even when the engines are parked, you get the lights and the sound and the rooftop beacon. So you've got something going on action-wise even when they're not moving. Okay, that's the middle of the third cycle. In a moment, in 7 seconds is the time delay before they back up. They'll start completing the third cycle. This could also be done rather than using that electric eye, or I should say infrared detector that we're using. This could be done with a magnet and a reed switch. set up like in some of the earlier videos.
We're ready to go.
But in that case, you'd have to put the magnet on each of the 3 trains, and it almost seems easier just to use the infrared detector for an operation like this. If you had a really long run, you'd probably want to use a detector at each end.
Tell them to close up. We're ready to go.
Like say if you were going maybe 30 feet, I'm going, this track is I think 16 feet 8 inches. But say you were going 30 or 40 feet, you might want to have a detector at each end because you wouldn't accumulate error in the middle. You'd be working off of each detector at its respective end. Again, as it's backing up, we're just backing up. There's no commands being given until we cross the detector. Then we start doing a time delay. And if the engine's running slower or faster, we'll accumulate error from the point we cross the detector. So we want to keep that distance not real long if we can. That's the end of the 3rd cycle. Let's look at the paperwork for this operation for a minute. And all this paperwork is on the web page at AutoControls-dot-wordpress.com, which is part of the AutoControls.org website. Just look for video 829, which is this video. And this diagram here shows our 16 feet 8 inches of track with our 3 engines on it, the yellow engine, the green engine, and the white engine, and here's the west end, and they'll all travel down to the east end. Now we can look at each engine individually up here, and we can see that each train operates on its own portion of the main line. In other words, the first engine to move, the white engine, travels from about here down to the end. The second engine to move, the green engine, travels from about here down to this point. The third engine, the yellow engine, starts at the starts at the west end and travels down to approximately here. So we can work the timing out of each of these 3 engines individually, and that's what I did. I figured about where I wanted them to stop with those white pieces of cardboard. Then I ran each engine manually at speed 2 and measured the approximate time on each side of the detector, and I could write a little routine to run each engine by itself and test that out, and then just combine them all into one routine. But each engine's doing its own thing, one engine at a time. So you can work on one train at a time, getting it to stop and start at the right places. And then down here, as I mentioned earlier in the video, if you were doing a long run, say the 3 engines start out here on the west end, and they took a really fairly long run down to the other end and stopped down here, you probably would want to have 2 detectors, and that would minimize the error because it wouldn't matter how much they slowed down or speeded up going around this part. Your only error would occur when you went across this detector. Then you just need to measure the time from this detector to where you're going to park each locomotive, and then coming backward, you'd come backward and measure off of this detector the amount of time to park each locomotive. But if you had one detector in the middle, like we did in this video, you'd tend to accumulate more error on a longer run. And you can use the exact same commands that we've used for this video, except 3 steps. You just change it to weight, change from weight to input 14, it goes to ground, weight to input 16 goes to ground, to account the fact that we're using another detector. I've assumed we're hooking the second one up to input number 16. Here's the wiring diagram for this setup, and it's pretty much the same as all the previous videos. In fact, I took the diagram from video 828, the previous video, which was running 2 N-gauge trains on a circular loop of track together and just changed a couple of things to use it for this video. But you can see here's the power, the command station. It's showing a Powerhouse Pro here, even though I'm using the power cab for the video, but it's our source of power. This essentially is the same thing as a TIU if you were using DCS, but in DCC they call them command stations. Here's our NCE Mini Panel, which is the controller, and this does have to be used with an NCE system. You can't use this with a Digitrax or a lens system. And down here is our Z-Stuff detector. This shows the wiring for a DZ1011, which is the basic Z-Stuff detector, even though I've used a DZ1012 in the video just because it has a brighter light, but you can use either one. And if you assemble these as a unit, like I've shown here with the dark outline, it could be basically considered a unit that has two wires going into it for power and two wires coming out of it that go to the hook up to the mini panel, and one wire is ground, and the yellow one I'm showing goes to input 14. And then this other yellow wire here, that's input 18, and the switch is on that. That's the input. We leave that switch open if we just want to run a single cycle, and we close that switch if we want it to keep repeating. In other words, our program tests whether input 18 is grounded or not, and if it's grounded, that is to say if the switch is closed, then it keeps running, repeating the program continuously. And the pink wire over here, that's the button on input number 1. We push this button to start the routine up, and we could have another button number 2 hooked to input 2. I don't have the button on my control panel. I just used that wire. But this, and when you look at this on the web page, it'll be in color. Here's our program for running these 3 trains. In a previous video, 816, called Getting Started with the NCE Mini Panel, I tried to show as well as I could how to program this thing. You don't really need to be a computer scientist to program this thing. You just got to get used to doing things the way it has to be done. But looking at the speed step, looking at the commands for this video, it's a fairly simple. Here's our first loco. We run the white loco, and we'll just go down this command column real briefly. We say select loco 733. That tells which loco we're going to control. Speed forward 2. That gets it moving at speed 2. Wait till input 14 goes to ground. That's waiting for it to cross in front of the Z-Stuff detector, and the detector will cause the Z-Stuff relay to close, which will ground input 14. Then we delay 27 seconds. We're using quarter-second intervals, but we're doing a delay of 27 seconds. And when that delay ends, we set the speed to 0. This has speed reverse 0. There's a speed forward 0 and a speed reverse 0, and they do the same thing. I'm doing the speed reverse 0 for this video because it puts the loco's reverse light on, and since I'm filming it from the rear most of the time, I get more lights. Then we delay a quarter-second times 4. That's a 1-second delay. Then we start the next engine down, which is the green engine. So we do the same thing all over again just for the green engine. Select loco 779, speed forward 2, wait till input 14 is ground. That's the Z-Stuff detector. Delay for 18.5 seconds. When 18.5 seconds elapses, set the speed to 0 to stop the loco, and then delay a second. Now after that, we'll just do everything all over again for the third loco, which is the yellow engine. Select loco 101, speed forward 2, wait till the detector wait till input 14 goes to ground. Delay 11 seconds, set the speed to 0 to stop the loco, and delay 7 seconds. That's the next thing that happens after this routine completes is we'll be backing the locomotives up, just doing the same thing all over again, but in reverse. So the yellow one was the last one to go down, so we had to bring it back first. It's already selected, so we just send the commands speed reverse 2, wait till it crosses in front of the detector. That's input 14. delay for 26.5 seconds. When 26.5 seconds expires, which should get it up to the end of the track right here to the left, then we stop at speed reverse 0 and delay for a second. Then we start bringing the green engine back, select loco 779, speed reverse 2, wait till that input 14 goes to ground, that's the detector, delay for 19 seconds, speed 0, and again delay for 1 second before we start the next engine. Then we can start the third engine, select loco 733, that's the white engine that's on the far end, speed reverse 2, wait till the input 14 goes to ground, that's the detector, delay 12 seconds, stop at speed reverse 0, and now we wait for 7 seconds here, and we do either one of two things, and this is the least obvious statement in these sequence of commands. If input 18 is open, that means that switch is open. It says skip the next command, so it skips over this link statement and goes to the terminate command and stops executing. So if the switch is open, if that connects to input 18, the locomotives won't run again. However, if the switch is closed, it comes down here, it won't do that skip statement, it'll hit the link statement, it says link to input 14. That takes it back up to the top of the command sequence that starts running the locomotives for a second cycle. Now we've got a second routine programmed into the mini panel that'll run just 2 trains. You can see the yellow train is gone, and that's initiated by push button 2. Now there's not actually a push button 2 hooked up, but I've got a wire hooked up to input 2, and if I ground that wire, it'll have the same effect as pushing push button 2 if the push button 2 were hooked up. Let's do that now. Now I just touched that blue wire to ground, which essentially connected input 2 to ground, which is the same thing as having a push button 2, which started the sequence for 2 trains. And it's basically doing the same thing as before, going down the direction, we're calling that east, the way that engine's traveling east. It's running the same time delay to get that white engine to the end of the track. Now it's before it'll start the green engine and take it down. And it's basically the same operation as with 3 trains, except when we back up, we can back up a little bit further because we don't have the yellow engine on the end of the line like before. That's about an 18-second time delay to get that green engine down there. Now that'll wait about 7 seconds. These time delays, of course, are all modifiable, but it's set to wait at the end about 7 seconds before it reverses direction. Now it's running free, so to speak, until it trips the detector. And once that detector turned to red, again, it's starting to execute a time delay. In this case, it's about, I believe, 26 seconds. So the mini panel, the controller, is going to wait about 26 seconds and then issue a stop command, which will bring this green engine up to the west end of the main line. Now the white engine is running free. It just gave it a speed command 2 in reverse direction, and nothing's going to happen until the detector turns red. Now the detector went red, so the mini panel is going to start executing a delay command 19 seconds. In other words, it's going to time for about 19 seconds, and when 19 seconds elapses, it'll issue a speed 0 command to the white engine and stop it. Now that's one cycle, and I've got the switch over here closed. This is a switch hooked to input 18 that causes it to keep repeating, so it's starting a second cycle, and again it'll keep repeating as long as that switch is closed. It'll keep repeating this operation. Here's the routine for running 2 trains you saw a minute ago, and it's just about the same thing as the 3-train routine, except we've taken the commands out for the yellow engine. You can see the yellow engine is gone. We just had the green engine and the white engine. So, and this starts at input 24. So it starts out by selecting the white engine, speeding it up, running it down to the end, and stopping it. Then it's, and again, same as before. Then we select the green engine, start it up, run it to the end, and stop it. Now we're done running both our engines, and we can do the reverse trips. So we select, the green engine's already selected. We just say speed, after we wait for 7 seconds, we put it in reverse, speed 2, run it up the other engines, run it up to the what would be the west end, and stop it. Select the white engine, run it up to the west end and stop it, and wait for 7 seconds. And then we have the same test here, whether to continue or not. If the switch is closed, which we want to repeat the routine, it'll come to the skip if the input's open, but the switch is closed, so it won't skip, and it'll do the next statement, which is a link to input 24, which means it goes up here to input 24 and starts executing these commands again. However, again, like the last time, if the switch is open, it skips over the link statement and comes to a terminate statement, and the routine stops executing. Now here's a demonstration with just one train on the track. This is more of a test routine. This starts at input 8. There's no push button hooked up to input 8, so I've hooked up this Pro Cab to the test port of the mini panel. We'll start it in test routine. So what I can do is say test operation, input number 8. When I select that, that'll start the routine that's controlling that single train. And this will do pretty much what you expect. This has been shown in some of the earlier videos using, I think it was one of the earlier videos used HO gauge and S gauge and large scale going point to point. Now there's our read switch being detected, and it'll run for about 27 seconds, which would take it down to the end of the track. In the earlier videos I'm referring to, I think I used a read switch in the track and magnets on the train, which is another way you can do this. But the nice thing about the infrared detector is you don't need to put any read switch in the track, and you can easily move the detector as I showed earlier. Now we're coming back in reverse. And again, it's just running free speed step 2 until the detector is activated. Okay, the detector went to red. The block detector closed the relay, so the normally open contacts shifted to closed, which grounded input 14 on the mini panel, which is what we're using to signal it that a train is there. So it started a it started a time delay about 26 seconds, and that'll bring this engine back to this end of the track, the east, calling this the west end, and pause it. Now it'll wait about 7 seconds, and then it'll start up again. There's no test in this routine for whether the knife switch is closed or not, because there wasn't enough memory left. This is just a simple test routine that keeps repeating, and to stop it I have to just do a reset of the mini panel. But this gives you an idea how it looks like with one train operating on the track. Now here's one of the 3 routines for running a single engine. This is for the green engine, and we ran this a minute ago in the video just on the track all by itself, and this is a routine we were using. Select Loco 779, started up, wait till the input goes to ground, delay for 18.5 seconds, speed 0, which is stop, then wait 7 seconds at what will be the east end, and we'll come back to the west end, so we'll start it up in reverse, wait till the detector closes a relay, go for 19 seconds, and stop, and then wait for 7 seconds, and then it just links to input 8 and repeats. And the handwritten numbers you see here that I wrote in by hand, those are what I actually used in the video that you watched that made it go completely from one end to the other. The printed numbers are what I was using for the single train operation to be part of the 3-train operation. In other words, it didn't go all the way to the east end when it went down this part, and it didn't go all the way back to the west end when it executed this part, because the green engine is in between the other 2 engines, as you recall. So I've got 2 sets of times I used here. Basically, this what was done in this video filled the mini panel. I could have put a terminate or continue routine here if I had memory, but we're just out of memory, so this had to be fairly brief. Just reviewing the configuration memory for this thing, we set the memory address 3 equals 3, and that means it's continuous memory inputs 3 and above. It'll flow from the commands in one input to the commands in another input. And in memory address 4, we set that to 4. We disabled inputs 4 and above. That means they won't respond to a push button. So we could have push buttons on inputs 1, 2, and 3, but we couldn't put an input on a push button on input 4 or 5 or 6 or anything above that, because they've been disabled. Just briefly looking at what commands are in this thing. We're starting at input 1. This has inputs 1 through 30 available for programming, and each input has what they call 4 steps. So in theory, you can write about 130 different commands 120 different commands for 30 inputs times 4 steps per input, 30 times 4 being 120, but in practice you can't use that many because you can never use them all efficiently. But at any rate, starting at push button 1, this is input 1 is where our push button hooks up to, and that goes to link the input 14, which is the 3-train automatic sequence. If we push button 2, we didn't have it hooked up but we had that blue wire, which we kind of use as a push button. If push button 2 is activated, that is to say, if it's grounded by either a push button or a wire, as you saw in the video, it'll link the input 24, which starts the 2-train automatic operation. And then we have this program. This is our test program, which is in inputs 3 and 4. And you could have a push button hooked up to input 3 that would start this program. I just use it in the test mode, but this has several skips statements in it. There's one for the relay, there's one for push button number 1, and there's one for switch number 18. That's the repeat switch. So if none of those 3 inputs are closed, it'll just skip over all these statements, go down to this bottom link to input 3 and go back and do it again. However, if the relay is closed, it won't skip this statement. It'll come to this accessory 2000 norm statement, which it says throw turnout 2000 straight. There is no turnout, but it'll make the LED blink, as you may recall from the demo. And likewise, if we hold down push button number 1, so that's closed, it won't skip over this statement because input 1 is not open, it's closed, and it'll send that dummy command. And finally, if the switch number 18 is closed, it won't skip here. It'll encounter this command to set that turnout straight and blink the LED. And then there's a half-second delay here, and it'll go back and repeat itself. You got to have a delay statement here, or it can't run at infinite speed. Now that brings us up to input 5. This is the single train routine for the white engine. Runs it down forward, stops, waits, and brings it back in reverse, where we could work on the timing for the white engine. This is the one we talked about a minute ago for the green engine. This one is inputs 5 through 7. This green engine is inputs 8 through 10. And then on the next page, we have the routine for the same routine for running just the yellow engine by itself. Takes it down to the end, stops and waits, reverses it, and brings it back to the west end. And that's inputs 11 through 13. And then the rest of this stuff we looked at, starting at input 14, is the 3-train routine. And this sheet is to take the engines down to the east end. The next page is the commands that bring them back from the east end back to the west end, and that brings us up to input 23, and then starting at input 24 and ending at input 30 is the true 2-train routine we looked at a minute ago. So that basically fills all the usable commands in our mini panel.